Here are some notes on the introduction of our trig ratios. Trigonometry is just triangle measurement, and the first ratio that we're going to look at is called the tangent ratio, and that's right here. A ratio is just a fraction, and all we're doing is setting up fractions. We're going to be using this right triangle right here as our model, focusing on angle A, which is right here. Everything is in relationship to the angle that is given. So when you're talking about angle A, what you're going to notice is this is the opposite leg because it is completely opposite the angle that is marked. And then this side right here is the adjacent leg because it is the one that is next to angle A. Now you might be wondering, well, what about this? If you remember from our right triangles, this is the hypotenuse, and that is going to come at a different ratio. So right now we have the ratio, the tangent of angle A. The ratio that's set up is you're going to use the leg measurement opposite A and the leg measurement of the one that is adjacent or next to A. And so the formula that you're going to be, or the ratio that you're going to be looking at, is right here. Tan equals opposite over adjacent. And these proportions will help determine angle measurements on the next lesson. But all we're doing right now is just setting up our ratio. So this example down here of tan x. Tan x, again, opposite over adjacent. And if you go ahead and take a look at the example, angle x is right here. The measurement of the side opposite is 12. And then the measurement of the side adjacent to it is 5, which is where you're simply going to get the tan of x is 12 over 5. And that's it. That's all we're doing. The tan of y, opposite over adjacent, but now we have to go to y. What is the side opposite y? Well, it's 5. If you go down there, you'll see it's 5. So you're going to write 5 here. Now you're saying, well, what's the side that's adjacent? Well, you've got a 12 and a 13. Remember, we are looking at sides adjacent. Adjacent means next to, so it's going to be 12. So this is 12. Why aren't we using the 13? We are not using the 13 because it represents the length of the hypotenuse. And that has its own special ratio. So now what I want you to do is on page 311 in your book, we're going to use these trig tables. And on the trig tables, I posted this on our classroom page, you might want to print it out. So you're going to find the tan of 35 degrees. So you're going to slide down your angle, you're going to see 35 degrees, and go over to the tangent. You'll see it says sine, cosine, tangent, and that is 0.7002. You're going to write that in the blank there. The other thing you're going to do is now you have to find the tan of what degrees is 0.1944. So you have to find that 1944 in the tangent. And there it is, go slide across, it's 11 degrees. So the tan 11 degrees is 0.1944. So now on these second pages here, this is from the book, page 306, and we're going to work on these. So taking a look at the tan of r, again, opposite over adjacent. So we have the tan of r, here's r. The opposite is 3, and the adjacent is 8. That's all we're doing. For the second one, the tan of R, here's R, the opposite, and the adjacent. Opposite is 13, the adjacent is 19. And here the tan of R is down here, the opposite is 15, and the adjacent is 8. No simplifying, no changing anything. This is all we're doing. For these 4, 5, and 6, you're going to find the tan of S. Same thing, except we're looking at S. Opposite over adjacent. And that's what you're going to do for 4, 5, and 6. And then using the trig tables on page 311, the tan of 24 degrees, find the 24 degrees, make sure you're sliding over to that third column, and you're going to have 0.44, 5.2. And then opposite that, it says the tan of what is approximately 2.47. And then that's going to be 68 degrees. So you're just going to have to use these charts. You can either print these out and tape these into your spiral, or you can handwrite them. They are also on the Google Classroom page for you to print out.